first got involved with Visual Studio and .NET, actually when we started prototyping .NET back in '96, actually late '96. At the time, we knew we needed some kind of programming environment that really made it easy to write code. We decided we needed to have a more modern kind of environment for that. So a few of us started prototyping something which turned into the CLR, or the Common Language Runtime. Like I said, never quite expected it to turn out like it did, but I've been 10 years in the .NET team, and then over the last year and a half with Visual Studio. Back in the early days, we had to make a lot of decisions around how we were going to serve a new set of developers. They were kind of moving off of perhaps writing a lot of C++, C and C++ kind of code, and they really needed a more modern kind of environment. With that, we knew we had to create something that broke a lot of new ground that included things like automatic memory collection, things like that, where you didn't have to worry about COM and some overly technical pieces. With that came a number of decisions. We debated a lot around things like, should it be tracing with ref counts like COM was, or should it be an actual garbage collected system? What kind of programming language would you use? We had Visual Basic, we had C++. Should we invent a new language, which ultimately we did, and also updated Visual Basic itself. So there was a number of things like that. We also had to decide what kind of workloads we would go after. For example, doing rich client applications, doing web, mobile devices, making those sorts of decisions. There was just an unbelievable amount of these sort of decisions to go make back in the early days. With respect to resistance on making these decisions, I mean, it's a big thing to say, I'm going to introduce a brand new programming paradigm and I'm going to convince all my developers to move over to it. That's hard. I mean, we did have systems, we had invested a lot in those systems, and they were functional and did the right thing. So, I would say there was the normal kind of skepticism around starting a big new effort like that. On the other hand, we were seeing a lot of people migrating onto new solutions. There was a need for this. And I think by the time we got out to the PDC in the year 2000, when we introduced everything for the first time, that was validated in a big way by our developer base. The risk of putting this many people onto a project, I mean, you can quantify it in a few ways. For one thing, we were halting development on popular products and moving on and building something new, and that was going to take some time. In addition to that, you don't build a modern development environment without putting a few hundred people on it. That's a big kind of expense and opportunity cost associated with it. And then when you start a project like that, you hope, of course, that it'll be quite successful, but you have to wait until you're done and see if people agree with you. At the start of .NET, I was basically a software design engineer, a developer, writing code, designing code, things like that. My part of that, honestly, I had probably some of the most fun I've ever had in my career. I was working on the file formats. I was working on the compilers for new languages like C# as well as Visual Basic and things like that. It was amazing to watch the system just bootstrap. Just being able to go in, and I remember the first day where we put the 50 of us in a room and we actually showed the Fibonacci sequence, that little program, running with hard-coded IL, and it printed out the numbers on the screen, which for a bunch of engine geeks was like, wow, standing out, that's just awesome, because we understood what was behind that, right? There was the requirement to go back and get compilers up and running for some of the class libraries. There was the file formats that we had specified, a new instruction set. There was actually the interpreter at the time, later replaced by just-in-time compiler. I mean, in other words, a number of components that had to come together. And these components, today you can look up on MSDN or any online magazine and you can see the block diagrams. But keep in mind, back in '97, that was really like, okay, there's 6 of us, let's split it up. I think we need a garbage collector. I think we need a compiler. I think we need COM. Okay, great. We all went off and wrote one-pagers in Word. This is what it would kind of look like. And then we went in and typed in the code. And then to actually, okay, we would actually hop from office to office. Hey, here's my code, let's hook it up to yours, go back and forth. And so that's like really exciting to see a system come to life. That was a few million lines of code ago. We did write probably 2 or 3 million lines of code in the first 2.5 years. That's across the entire product, not just literally like my team, but between the CLR, the class libraries that were built on top of it, the Visual Studio tools and things like that, we really were bootstrapping the entire thing from scratch. And I wasn't there when something like Windows came online, but I can imagine that it probably had a similar sort of feeling as you first saw the screen start coming up and the system start to work. It's always a really fun time with a big software project. life was really hectic at the beginning, right? Because of course you are kind of an incubation project as well. So there's always this, should we really keep investing in this? You're kind of making some progress, but you're like, I really need to see the next milestone go. So there would be times when I would basically leave at 35 o'clock in order to, see my family or something. And literally as soon as we had dinner or whatever, I would stay up until 2 o'clock in the morning. I go write another 300-400 lines of code, around some piece of the file format or some kind of, prototype, or something like that, and then come in the next day. And I, of course, was not the only one doing that. There was, tons of people that were doing that. And then you start throwing the subsystems together. And again, these are namespaces that today you just say, system dot, interop dot, whatever. But we had to go create all that stuff from scratch. We did literally go type it all in. So that's what it was kind of like in the early days. When you come out of college or university today and you're writing code, it is kind of amazing because there's these just, unbelievably, these tools that we've built. They're kind of what you expect to have. Whereas, frankly, when you're bootstrapping a system like this, we wrote a bunch of the code in C and C++ and a lot of assembly language. And so we'd be using low-level debuggers. We made it target Windows 95, Windows 98. So we were using serial-level line debuggers on it and looking through hex dumps and stuff like that. I mean, it's kind of like that movie, The Matrix, right? I mean, there's after a while you get to the point where you're looking at this just dump of numbers and you see the picture kind of pop out of it. And thankfully that is one of the values we provide with the system. You don't have to do that kind of development work today. We've done a lot of that hard work for you, inside of the system. That was one of the appeals of building the system in the first place. So spoiled, sure, I would have loved to have had that myself. Nonetheless, somebody has to go build that, and I'm glad that our system is making it easier for people to write code today. The level at which you work and, does it make you a better developer? I think we've kind of changed some of the equations. So whereas you used to have to spend an inordinate amount of time doing, what might be some grungy programming kind of stuff, finding leaks in your code, finding places where you're, using a bit hose with a pointer pointing the wrong direction, corruption and stuff. Those are hard and really hard kind of bugs. And do you really need to spend your time doing that? I mean, that's kind of annoying. So, honestly, I'm happy that people can actually move up level and solve different types of problems. Another example, I used to write custom GUI code at one point too on our product, and I used to handle every little mouse click and pixel click and dragging columns bigger and smaller, and it's like, is that really what I want to spend my time on? Or, today I've got WPF, I can just basically declare a data grid and poof, it just does that. So now I spend all my time adding value on top of that. There's still hard problems for me to solve as a developer, but the amount of code that I can write and the way the code looks is so much better than what we used to have. So when we released the first version of the product, at that point, I believe I was actually development manager, like in charge of all the engineers for the CLR team, as part of .NET. Things were very interesting then when we actually announced this, because at the time, Microsoft itself, we really didn't talk a lot about future development. In fact, I'd actually worked on this system for, over 3 years and hadn't told anybody about it, right? And so at that point, being able to announce the product and show it, like when we went to the PDC in Orlando, it was amazing because our customers were seeing something for the first time. In fact, many walked into the show kind of thinking like, yeah, I don't know if these guys have anything new for me. Why would I even pay for the ticket? And then we got actually people that were upset with us because they were saying, if I'd have known that's what you were going to talk about, I would have bought a ticket too. Why didn't you tell me? My goodness, So that was an interesting kind of cultural change for us. For me, it was, and for the team, it was very exciting because we'd worked on it. Interesting things that would happen, like during the keynote where we showed it off for the first time, we actually showed a combined call stack that included, I believe it was COBOL and C# in one call stack. And I was kind of sitting in the back of the main auditorium, and everybody erupts in applause. I kind of looked at my teams, for a second there, I was like, well, what's the big deal? And it's like we finally realized, like, wow, I mean, that's the first time you really had that great kind of interop between languages. That was the promise of the system. But frankly, we typed that code in 2 years ago, right? I mean, that was just like a day-to-day thing. So it's like, no big deal. You know what I mean? So it was like, wow, that's right. We haven't shown you that, right? So there was a lot of excitement around that first version and showing off some of that cool things. Very fun. We didn't talk a lot about early development. A lot of that was just common business sort of thing at the time, which was we have product in market, we're selling it, we don't want to confuse people about, new versions coming out and things like that. I think one of the great cultural changes that we've made, especially in the developer division over the last, 10 to 15 years, we transitioned out of that mode, and we've spent a lot more time trying to be open and transparent about here's what we're doing, here's what we're working on. And so, for example, I didn't have a blog. None of us had blogs, didn't even know what a blog was, some number of years ago. But really, that's become an integrated part of how we communicate with our development. I get generally 2 or 3 customer questions a day just coming through from my blog saying, hey, I had a gentleman in China just yesterday trying to get the C++ compiler working for a kernel driver, able to hook them up and answer a question. We turn around, I've actually released the new UI for the latest product, so people could see it before they can even touch it. And actually, they gave me feedback. We've actually already changed it before the beta. They won't even see the piece they didn't like. All right, that's kind of cool. So that kind of transparency, I think, is a big cultural shift that we've made, like I said, over the last 10 years or so. I think in the development community, people are looking for a level of transparency so they can plan out their products and things like that. And if you look across the offerings they can choose from today, they want the ability to give you feedback early on what it is you're building and say, hey, I like this, I don't like this, that sort of stuff. And so we've made this sort of cultural shift on being more open and transparent. Like I said, we get feedback much, much earlier now than we used to. Used to be I'd give you the beta, you'd give me some feedback, I'd improve it, and frankly, if it didn't make it in by the end, there may be a chance that it never did until the next product. Like I said, just my ability to go blog the new UI and the latest product, people gave me feedback, the team actually took it, we haven't even released it yet, boom, they fixed it. So it's like, that's a really great way to get feedback and really take that in early. So it really is asking our developers to be an intrinsic part of defining what the release looks like. I think having this transparency is a good thing. We get this constant flow of information. That's a really great thing to see. It does have its challenges though too, right? Sometimes we may present new ideas and we have to do it in a clear way because how do we separate ideas that we have that may never come true versus ideas that no, this is really the product and what it's going to look like. And so I think we've had challenges around showing stuff too soon and getting people excited when maybe we weren't ready as well. That's something we've been trying to learn from over time. In the time before the first version of .NET, you had to look at what our programming assets were. They were really great. I mean, we had C++ and MFC, and it's still popular and useful today. We had things like Visual Basic for writing line of business applications and also some ISV applications, things like that. But there was also the emergence of the web. We knew that was going to be a big thing, and there wasn't great programming environments, especially for writing server-side components and things like that. We knew we needed to come out with technology that would do that. In absence of that, boy, how would people write what today is pretty common, which is middle-tier logic, business logic on a server, connected up to a website and things like that. We did have technology like ASP, classic ASP, and that served a purpose, but it wasn't necessarily there to scale in an enterprise kind of way. And I think then what we've seen over the last 10 years is, especially in the enterprise server market, a lot of enterprises have moved that kind of logic over into that middle tier sort of logic, big sophisticated systems that can scale incredibly well, and then really, really large consumer sites, social networking sites and things like that. I don't think on our original technology, either writing unmanaged code or writing that with maybe some of our older web technology, I'm not certain you'd have reached the same level of scale. Good technology, but I'm very happy with the investments that we made. In 2005, that product, which was built on top of .NET Framework 2.0, at the time I was the product unit manager, the POM, essentially the lead for all the engineering for the CLR, the Common Language Runtime component, so that part of the base. 2005 was a major, major release for us. At the macro level, we did a number of features down in the runtime. We did the generics features, that enabled some of the future innovations. We did integration with SQL Server and other database products and things like that. We just did a number of scalability issues in perf, and we worked on a whole bunch of things like that. When you get into Visual Studio itself, then we added a lot of features there around new designers. We made the product a lot easier to use, for Windows Forms and ASP.NET. But in addition to that, probably the biggest thing we did is we added the Team System, suite product of offerings. So basically ALM, application lifecycle management, so source code control, the ability to do advanced development and architecture and things like that as well. So that was a big, big, big major release for us. The feedback on it has been very good on the product itself. It is still a very popular release of the product. The challenges we face along the way, boy, we put a lot of functionality into that version of the product. We made a lot of big decisions. We created a brand new product category, with the team system work. It was a brand new version of the CLR, a brand new version of Visual Studio, a brand new suite to go along with it. Wow, that was a lot of work. There was a lot of challenges for us in pulling this together, just the sheer amount of engineering capacity required to get everything working very well. And then, from a customer perspective, of course, having a new version of the CLR to pick up meant that you had to, pull your applications forward with Visual Studio, new project formats, and then with the new source code control system and things like that, you needed to go adopt that. So, there's the usual sort of, warming up curve that one goes through when you acquire a new product like that. Developers, and I am a developer, so maybe I get to say that we have kind of a, we do like to point out where there are issues with stuff. With 2005, I think developers there, again, porting to a new CLR, I think is an interesting thing, the new file formats and stuff like that. I mean, it's a lot of work to adopt a brand new version. Once we finished up the 2005 product and we got done with the .NET Framework 2.0, and we finished up that version, we were then starting to work on something new. I knew we were going to need a more factored version of .NET, something that was a little bit smaller, because we had a whole bunch of great functionality in .NET Framework 2.0, but we also needed something that was going to work maybe closer with the web. At the same time, Silverlight itself was starting to form. It didn't even have that name yet, but the technology was starting to form, and we knew we wanted a very lightweight, small, fast to install runtime, something that could run very well inside of the web, kind of have really great graphical experience for you, but an easy programming model. And we just, got all of our developers onto .NET, and we've taught them those skills. And so one of the first things I had the team do was then start working on a stripped down version of the CLR and the .NET Framework. So we spent a whole bunch of time going through feature by feature, gave ourselves a budget and said, well, for this kind of environment where it doesn't just come with Windows, how big should the thing be? And we had to go through, make architectural changes, and this is in and that's out, and what kind of program could you write by the time you were done? Would the tools work against it? Would the debugger still work? And then, by the way, we made it work on the Macintosh. So, okay, I better go make sure that I can debug with the Macintosh, and it better feel like Visual Studio when I do that, right? And so we basically spent a lot of our time after 2.0 getting that system up and running. With the 2008 product, we concentrated on doing a lot of work inside of the IDE and the languages. I would say one of the really, very interesting and compelling features in that release was the introduction of LINQ, Language Integrated Query. It was a kind of a really great way to think about writing code that Anders Heilsberg, came up with. It really made it easy for you to do things like, common programming. I pull in some kind of XML document that maybe comes from a vendor, and I want to check it against quotes in a database. And ordinarily I would write all of this procedural code that might be hundreds of lines of open this and loop that and blah 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 blah. It's like, well, gosh, SQL did such a great job with their grammar. Like, why can't you just do that in the language? So conceptually, I like to think of it that way, where I can just say, well, look, I'm coming from this document, I'm comparing to that database, I'm pulling it all together. It's very expressive. So we spent a lot of time developing both the language, for that, some of the runtime components for that, and then also the tooling so that you could literally type that in, have IntelliSense, make the debugger work, all that kind of stuff. With the launch of 2008, I would say the other thing that we did well there is we really worked hard on our internal engineering systems as well. And so we worked hard to kind of get more the proper granularity for feature development so that teams could kind of work better. And it was actually one of the more reliable cases where we kicked out the product and really got things kind of working along the way. Now, we changed fewer things. For example, the runtime itself was based on existing versions of the product. We added a few class libraries, but we didn't change the CLR. That made the engineering a little bit simpler, and then for our customers, they actually got the same version. The CLR team, of course, was off working on Silverlight, and so we now gave that innovation there. So they were, of course, very busy as well, but that made it a little bit easier. So we've been working on the 2010 product, well over a year at this point when we first started figuring like, hey, what are the key features and things like that. We've got a great release where I'm doing a whole bunch of work inside of the core IDE. We're actually making the product WPF enabled. So we're using our own, we call it using our own dog food. It basically means, hey, we ship .NET Framework 4.0, we're built on top of .NET Framework 4.0. We ship WPF, we're using WPF. So we have really great vector graphics built in for the engine. We are making language improvements both in Visual Basic and C#, and we're introducing new things like F#. In addition to that, we've added new tooling for other platforms. So SharePoint Tools, for example, is a brand new place where we've added tools. We've also made a big investment in parallel computing. So we have runtime libraries and profilers and debuggers and tools for doing that kind of work as well. And then we've never stopped actually innovating on the web. So all the stuff you've seen with Silverlight, MVC controllers, things like that, those will come along as well. So this is just basically for .NET, and then on Pro. On the team system side, we've introduced another new set of functionality there as well. We have a new lab management product for virtualization. We have new things for running manual test cases and also UI and record and playback feed work. We've got a new set of UML support in the architecture system, and we've done historical debugging, which means it's kind of like a DVR for your debugging sessions. And then we've tied all those products together so that when you find a bug in one place, a tester can file it, a debugger, a developer can open it in the debugger, and it just, it all kind of hooks together. So this is another really major release in the same way that the 2005 way was a big major release. So we've got a lot of great functionality. So for the 2010 release, so I run Visual Studio now, so I'm feeling a lot of pressure on 2010, right? So I've been here since day one for 2010, and it's a big chunk of the plan is mine and of course my team. But just having the team here and we're executing against it, yeah, I'm feeling a little pressure. We haven't published any final launch dates yet, but the way I like to describe this is we're kind of at that point for our first beta where the flight crew is telling you to buckle up and put your stuff away and get ready, because frankly that's about where we're landing. So we're getting very, very close on the first beta, and then of course we'll take feedback and move on to the second beta. But we'll keep taking the feedback. I think the customer expectations for 2010 will be quite high. I mean, we have been talking about it since the PDC last year. I did the Tech Ed EMEA keynote. We talked about Visual Studio 2010. So we have a lot of great functionality we've been telling people about. With the betas, we'll now start getting firsthand feedback. We've gotten some early feedback from some of our MVPs and kind of close partners that are trying it out. Feedback there's been good. So I'm looking forward to it. I love this cup. Every time I show it to a developer, they just crack up. With the .NET Framework 2.0, we added a feature called generics, which is a programming. So this is literally code. I can declare a type, and it's common when you have this kind of programming environment that whatever class it is you're specializing is called T, right? And so one of the guys in our team, Anthony Moore, came up with this and got cups printed out. So it's literally a cup of tea, but it's cup of tea. So so it's geek humor. But I love the cup. What it represents from a feature perspective is this deep work that we did in .NET Framework 2.0 called generics, and we turn around and put that into both C# in addition to Visual Basic, and it wound up being a core part of some of the features that we added in Visual Studio 2008 for the language integrated query, or the link feature. It was a core underpinning for that, because you combine that and Lambda expressions and things like that in the C# compiler, and all of a sudden, boom, this really just very expressive kind of language pops out in a way that frankly was very hard to do in programming languages before 2008. In Microsoft in '92, when I started, boy, I think we had 10,000 employees, and we're like 90-some thousand now, I believe. Things were a lot different. Your product teams were a lot smaller. In fact, at the time, I had actually came from IBM, where the product that I worked on fit on a box of tapes that you loaded onto a machine. And it had everything on it, which was pretty cool. Compilers and runtime database, all the rest of that kind of stuff. But it was tapes, right? So trying software out was kind of hard. So I remember coming to Microsoft in '92 because my product fit on a floppy, and I could compile it on a machine. I loved that. That was really kind of cool. So, okay, it's almost, I guess, 17 years later, and well, I mean, our product is like DVDs, and they're large and it has everything on it, so we kind of got back into the same mode. But it was a lot different. I mean, frankly, I've pulled more all-nighters working at Microsoft than I ever did when I was in university, as an example. I think today what's interesting is you have broadband, I have terminal server, all these other sort of products. So it's amazing. I still probably work about as much as I did back then, but at least I'm at home when I'm doing it, and that kind of stuff. Microsoft could be fairly rowdy, yeah. I mean, I remember a couple of things. I mean, back in Building 17, they used to have Swing Around the Wing, which is basically playing golf in the hallways with real clubs and balls and stuff like that, which is kind of fun. When Windows 95 was launched, that team basically ran around campus with like super soakers and shot up the place everywhere. In fact, even during one of our launches, I think it was 2005, we had so much champagne up and around the air, splashing everywhere, we had to literally go back and replace the carpets the next week because we did kind of ruin it. So it was a fairly rowdy, kind of environment. And now, boy, I don't know, maybe, I have 3 kids and, maybe you kind of cool down or chill out at some point. It's not quite as rowdy as that. We still do manage to have a lot of fun, and it's still a very fun environment. I still get energized every day when I come into work. There are always new problems to be solved. I mean, because as we invented some of the .NET work, and in particular, if I think of examples like middle server tier, web workload kind of stuff. Well, hey, now we're getting, again, another resurgence of the internet browser, right? And so there's lots of brand new innovation happening there. What are we doing about that? Every time in the industry, you can look back and somebody makes a decision and decides, you know what? Programming language wars are over. It's been decided. It's like, well, you know what? I think people have said that probably 4 or 5 times along the way, right? Some new paradigm comes along, some language or runtime or environment or tool is best, suited to kind of handle it, and it starts off a new wave of innovation. So that's the fun thing about this industry is that, I can use my skill sets and apply them forward, but, it's always going to be changing. Keeping the software ahead of hardware innovation, it can be hard. There's a long period of time where really what was happening is the chip manufacturers just got better. So we could keep writing the same kind of code, and frankly, it would just keep running faster. We're kind of at a point where we've exhausted some of those limits. That's why in 2010 we invested in parallel tools, so we could actually make it easier for you to take advantage of more cores on common machines. And so at that point, we're taking advantage of that. But in addition to that, you have things like mobile environments, much smaller devices and things like that. We provide tooling for that. I think another interesting inflection point is the cloud. And in the future, will I ever even see the hardware that I run my code on? Well, frankly, if I host my own websites today, I don't, right? I just basically upload my website and I probably let a hoster take care of it. What if more and more of my code runs that same way? So that's an example of the way things change, increasing broadband access, wireless access, smaller form factors that are much more powerful, more and more compute power and storage in the sky, more and more processors, on the desk. I don't think there's a shortage of innovation to go after. 20 years from now, I mean, it's very, very clear that a few things are happening already. The increased access, like I said, to wireless and broadband and things like that means we're in a much more connected society in the first place. I am taking more and more of my work with me. It's just sitting in my pocket, right? So that's clearly going to continue to happen. This kind of, convergence of, social networking is a way for me to communicate with my friends and things like that. Clearly that's going to continue to happen. Then I think you have to factor in what's going to happen with emerging markets as the rest of the world, kind of comes along, and that's why, things like mobile and cloud and being able to handle geo-distributed software is a very interesting thing for us to do. So I think we'll see computers in more and more places, and frankly, by the time my kids, 20 years from now, and they start their own families, wow, I mean, just look at what's been so different for us over the 20 years that we've just seen. It's pretty amazing. I think every time you think we've got it all, I like to go back and look at the pictures from your family reunion from 20 years ago, right? Okay, where was your cell phone? What you got your big honking TV? You know what I mean? Did you even have anything but a hardwired line coming? I mean, like, I think things change, very rapidly with the computing power that comes out, and I think software's always been there. Hardware trends, I think, are getting very interesting, right? And with smaller form factors, like I said, mobile form factors, stuff in the cloud. So I think there's a bunch of stuff. There's going to be 3D. You're going to have, more immersive viewing experiences. I mean, the, interaction and control. If you just even look at things like accelerometers on my phone, maybe I thought, like, who needs that, several years ago. But now it's like, how many games and things are driven off of that? So. Wireless controllers, the whole 9 yards. I mean, I think there's a bunch of stuff left to come. So in the whole Visual Studio franchise, favorite product, wow, that's like asking a father who their favorite child is at this point, right? That's kind of hard to answer. I mean, I guess, I'll always, of course, have a lot of affinity to the runtime, which I help build, because I think anytime you do that, you have a great attachment to that. If I really think at what's been the core, what's there, you know, frankly, what developers do on a daily basis, I pay a lot of attention to. You know, I'm editing, I'm compiling, I'm debugging. Because as a developer, I spend so much of my day just doing that day in and day out, and boy, that's got to feel like a really great experience. That's all got to come together well, right? So I kind of feel like if I do a really great job at that, and then I'm able to build the rest of the product on top of it, then I think we're in good shape.